Hello and welcome to another part of this tutorial on C. My name is Rohit Das, and in this video I'll be explaining arrays, mainly arrays in C. We'll be looking at what is an array, how to access an array, how to work with different kinds of arrays, right? And how to pass an array to a function, how to make a function return to an array, and a lot more. Alright, so let's get started. Alright, so an array is basically a set of contiguous locations in memory, right? So if you imagine memory to be something like this, right? Set of locations. These are called the lines in memory, okay? These are called the lines, right? And then each memory location has a particular address. Let's say this one starts from 1001, and then we have 1002, and then we have 1003, and so on, right? You get the idea. So what an array is basically these memory locations one after the other, okay? So first memory location is this, followed by this one, and then we have this one, and then we have this one. All right, the memory locations are not arranged in an array in such a way that first I will be having this one, and then I'll be having this one, and then I'll be having some in some random order, right? It's not a random order. It's basically a sequential collection of memory locations, okay? So if we look at an array conceptually, so the array is basically represented by this long bar over here, which has certain segments. These are the locations where values are kept, right? And these locations can be accessed individually. Let me write that again. Values, okay? So these are the places where values are kept. We can store numbers over here in any format. This is an integer. We can store decimals, floating point numbers, right? We can also store a character maybe. But one thing is for sure, that in one array we can only store only one kind of data, right? So if an array is meant to contain integer variables, it will only contain integer variables and not float or string variables, right? All right, so we can fill up this array over here. 1 2 3 4 5 6 7 8, whatever, right? So we can fill up this array over here, and just like I said, an array is a set of memory locations, right? So why do we need arrays? We already had variables which are also memory locations. We're giving them a certain name like int a equal to 10, right? I can also access a memory location like this. I can also store values like this, and I can access it using a variable. Well, you can also access an array as well using an array variable, right? So what is the advantage of using an array? Well, suppose you have a list of students. Let's say we have Mark, then we have Peter, then we have let's say my name, right? Now suppose I want to store the marks of the students: 96, 95, 92 perhaps, right? So suppose you want to store all these marks over here. Suppose this marks in computer, right? So the easiest thing that we can do is that we can uh, make variables using the name of the students and declare them maybe as doubles, right? And we can store these marks. Now here I have only 3 students. Imagine if I had 1000 students. So that would require me to have 1000 variables, right? That's just mind-boggling. And while programming, if you're writing a big programming where you have to maybe manipulate with all the marks, this will be becoming very cumbersome. Dealing with 1000 variables and remembering all of their names, this will definitely lead to an error. So instead of using 1000 variables, we'll be using a single array which contains 1000 memory locations, right? So that will be becoming much more convenient, because we can access the whole array using one single name, right? Maybe let's say I name it as marks. This will be pointing to the first memory location of the array, right? And since it is a contiguous location, I can simply access each of them sequentially, right? And it is much faster as well, because the memory locations are sequential. I can easily access them, right? I can directly access the 1000th marks, I can directly access the first marks, I can directly access any of them, right? And this becomes much convenient, and this is the primary advantage of using an array, right? So now I'm going to show you how to create an array in C and how to store values inside it, right? So in C, you first have to mention the variable data type, right? So like in normal variable names, we always mention the data type first. It can be int, double, char, anything, followed by the name we want to give to the array. Let's say marks, like we had done, followed by third brackets. So these third brackets will tell the compiler that instead of being a normal variable, this marks will be pointing to the first memory location in the array, just like I had shown, right? So why does it point to the first memory location? Well, that's the point of the array. It doesn't need to be pointing to the whole set of memory locations, right? It only has to point to the first memory location, and I can then access the other locations just by going from there in a sequential order, right? Imagine if you have a set of files and all of them are numbered sequentially, okay, and someone tells you a random number to pick out a file. How long will that take? The same concept is used over here, right? And then we have to mention the size of the array inside. Let's say we are taking 10 for simplicity, okay? So this is basically declaring the array. I'm telling the compiler that compiler, make an array, I mean allocate a set of memory locations. How many memory locations? 10 memory locations. How will I access them? Using the name marks, okay? And what will be the type of data that the memory locations will store? That is integer, okay? And as we had seen in an earlier video, an integer probably takes 2 bytes to store, right? So each of the memory locations will have size 2 bytes to store an integer, right? Alright, so this is how we declare an array. Now what if we want to store some data in the array? So there are some processes we can follow. We can first of all, I'm going to teach you the set notation, right? The initializing an array in one line, okay? So what I'm doing here is I am creating a set of values. Let's just create it. 96, 95, 94, 92, 98, 98, 100. Some topper has to be there. Okay, so how many values is that? 7, 8, 9, 10. Okay, so we have 10 values over here, right? Okay, and I am creating a set of integers. This is the set of integers enclosed in curly braces, and I am assigning this set to this array. Now what compiler will do is that it will check all whether there are 10 elements or not, right? And then it will simply assign them to the array. It will just simply store it. So 96 will be stored in the first location, 95 will be stored in the second location, 94 in the next location, 92 in the next, and next, and next, and so on, right? So let's compile that. Oops. Right, so this won't be giving us any kind of output because I haven't used any printf function, but since the program compiles, gives us a notion that the syntax is correct. Right. There's another way we can create an array using predefined values, right? So what I can do is that I can simply remove the size, because the compiler is getting the number of entries from here. So since it's getting 10 entries, it will automatically create an array of size 10. If there were 11 entries, it will automatically create an array of size 11. I think this is better because let me show you something. So suppose I give the array as size 10, right, and then I assign it maybe, let's say, 11 elements, just for experimentation. And as you can see over here, it gives us a warning: access elements in array initializer. Okay, now since this is a warning, this won't be fatal to our program. So what's basically happening is that the compiler checks that I have told the compiler to make an array of size 10, but then I am assigning it 11 elements. So that's why the compiler warns me that if you do it in some part of the program, it might crash. Okay, so I think the best way of initializing an array in this way is just not to mention the size at all. Okay, and this won't be throwing any error or warning for that matter, right? And this compiles perfectly fine, because the compiler takes the size of the array from the number of the set of elements. Okay, I mean number of elements in the set. Alright, so this is one way of initializing an array. Another way of initializing an array is to use a for loop, but to do that I'll have to teach you something else. I'll have to teach you the indexing of array, right? Alright, so initially we have studied that where's the picture? Over here, I believe. Yeah, so here we have studied that an array has memory locations, physical memory locations, right? So what compiler does is that in the matrix that we had studied earlier, I mean not the matrix, the set of marks that we had entered earlier, compiler just sees the set of marks and puts them in a sequential order, right? But where does the sequence start? We are not supposed to know that, because that's the thing about programming, right? We write a high level language so that we can avoid these low level abstractions, just so we can avoid these low level petty things which the computer can handle itself, right? So how can we know where the sequence starts? Where from shall the sequence start? So that value is actually stored in the array name, right? So what I had written in the program, let's write it down over here again. Int marks, right, equal to some set of values, right? So what happens is that this variable over here stores the actual starting location of the array. Like I had mentioned before, it points to the first place in the sequence, right, as I've pointed here. But then how can we access the rest of the elements, right? So since marks stores the address, we can simply add a certain number to get to the place. Like suppose if I add 0, it is going to access the first element, right? Because anything plus 0 gives the number itself. So if marks is storing the address, let's say 1001 plus 0 will point me to this address over here. Similarly, if I do plus 1, it will point me over here. If I do plus 2, it will point me over here, and so on, right? So instead of adding a number, we cannot add a number directly like this, because the address isn't stored as an integer exactly. Okay, and accessing a memory by adding values isn't very feasible. So C has provided us a way of accessing memory locations very easily. We have the concept of indexing, right? So what is indexing actually? So let me draw another array over here, right? Anyway, so let's say the first location is 1003, right? And the next locations are contiguous, so you can easily calculate what the other locations are. So we are no in no way gonna know that this array starts from 1003. Only the compiler knows because it has stored the value in the marks variable. But we also don't know what the value of the marks variable is. Actually, we don't need to know it, right? So what the indexing thing does, it assigns numbers to each of the memory locations. It assigns 0 to the first location of the array. Let's say this one is ARR, right? It assigns 0 to the first location, 1 to the next, and 2 to the next, and 3 and 4, 5, 6, and so on, right? So this is indexing. So what compiler will do is that it will simply take the index and add it to the base address. This is called the base address of the array. Let me write it down. This is called the base address. Why base address? Because it is the starting point of the particular array, right? So what compiler does is that it takes the index that we have passed, it adds the index to the base variable, I mean the base value, and simply gets the location that we want to access. So if you want to access the fourth memory location, what compiler will do is that it will simply take the base address and add 4 to it to get to the memory location directly, right? Now the thing is, how can we use the indexing property in C? It's very simple actually. Let me just erase this set thing over here, right? Let me assign it size 10, and then how I can access is that I can access it in this way: the name of the array followed by the index inside the third bracket, and then I can assign it a value, right? So it is 98. I just assigned 98 to the first location. Similarly, I can assign, say, 95 to the fifth location. I mean the sixth location. Why sixth location? Because if you carefully look at the diagram that I have drawn before, the indexing starts from 0. So the first value is stored at index 0. So the second number will be stored at index 1. Similarly, if we follow this, the ith value will be stored at I minus 1 index. Okay, and as you have guessed, if an array has a size n, the indexing starts from 0 and goes on up to n minus 1. Okay, so instead of assigning values to each of them separately, let's just use a for loop and take a user input, right? We have learned to take user inputs before. Comma I, we can declare variables of same type in this way, right? Same data type, mind it. So we'll start from index 0, we'll go up to 9, that's less than 10, not less than equal to, mind it. And we will be assigning it values. Say scanf %d marks I, right? You can put a printf over here to say enter marks for 10 pupils, right? Okay, so similarly I can also access the array to print the variables, right? Let's not write the loop again. Copy this thing, yank it, and then paste this thing over here. Okay, alright. So simply change this to printf. Okay, and then put a space over here and end it with a new line. Right. So what this program is going to do, we're going to print this line. We're going to take input for each of the places in the array. Mind it, for each of the places starting from 0 up to 9, that's less than 10, and then we are going to print all of them. Okay, pretty simple program. Let's see if it compiles. Okay, so there's an error over here. Yeah, should have used ampersand over here. Oh, sorry. Right, so each of the memory locations are now acting as a variable on its own, so that's why I have to use ampersand to actually pass the address instead of the value. Okay, here I am passing the value to the printf function, but by just simply putting an ampersand before marks, I am passing the address, the memory location. Okay, right, be careful about these. Oh, I didn't save it. Right. So let's enter 10 marks: 95, 98, 96, 95, 97, 100, 100, 85. We have to keep track of how many digits we enter. 1, 2, 3, 4, 5, 6, 7, 8, and 2 more. 9, 10. Right. And it prints all of them. Right. So now we know how to access an array, how to create an array, right? How to store numbers inside an array. Okay, so instead of doing scanf, instead of taking user input, let me just show another thing. We can also assign expressions to the place, just like we can do to a variable. The expression evaluates itself, a number is printed, and then it gets assigned. Okay, so let's say I want to store the square of the number I. Let's say make it I plus 1. Put some brackets. Right. Right. So now let me just erase this line over here. So what it did is simply calculated the square of the number I plus 1. So for 0 it will be calculating the square of 1. For I equal to 1 it will be calculating the square of 2, and so on. Okay, so now that we have learned how to store inside an array, how to access an array, how to print an array, let's see what happens if we try to store something of a different data type. Right, so here marks is assigned to store integers. Now what happens if we try and store a float inside? Right, let's compile that, and it runs. Right, but it will be printed as an integer. Let's see what happens if we try and print it as a float. Will it be printed? It won't be printed because I'm passing the memory location itself points to an integer, right? So even though float takes much more space, it will overflow basically, right? It will be stored as an integer nevertheless, right? Okay. Still, let's try and print that thing. Right, so as you can see, it gives us zeros. Why? Because there aren't any floating point numbers in marks, there are only integers. That's why it gives us 10 zeros. Right, so let's go back over here, change this. Right, this one over here. Right, so you can check it out to see what happens if you try and store characters, etc. Alright, and now we shall be going on to using functions to which I'll be passing an array, right? Okay. So here I'm running a for loop to calculate the square of I plus 1. Let me use a function to calculate the square. Let's say void, since it's not going to return anything, square int marks. Mind it, there won't be any error because the argument that I am passing into the function is available only inside the scope of this function and not outside. Okay, so let's say for int right, int I equal to 0, I less than n, mind it, since I know that I am storing 10 elements, I can use 10, but if you want to use a variable for the size of the array, you can pass it in the function, right? Alright. So this is going to calculate the square of the values, right? And we are calling this function square marks over here, and let's see if that works. Oh, I did something over here, right? It should be L. This L would have been valid if we had passed it as a parameter in the function, but let's just stick to our constant sizes. Alright, so as you can see over here, this is the way we pass functions, I mean arrays to a function. There's another way, a more logical way, but we'll be discussing that when we start discussing about pointers. Alright, and another thing I want to tell you is that another way of calculating the size of an array, right? You cannot calculate this way by passing it as a parameter. Just a moment. Right, so if you are passing the array as a parameter to a function, you cannot use this method. Okay, why you cannot use this method, I'll come to that. But if you have the array over here, right, already declared, the size may be given, but suppose you have a large set of elements and you don't know the size. So the best way to calculate the size of the array meaning the number of elements, you can use this process over here. So what this does is that it basically takes the size of the whole array in bytes, divides it by the size of one memory location in bytes. So if you have 10 memory locations of 4 bytes each, this will return 40 bytes and this will return 4 bytes. So 40 by 4 will give us 10. Okay, let's compile that and see what happens. Right, so as you can see over here, it returns the value 10. Okay, and now we shall see how to make a function return an array. Alright, so returning an array is a bit tricky. We'll go through it slowly. Right, so let's say we have no array over here, we only have I, and this does not take any parameter. Okay, and since it's okay, and return marks, I am creating the array in here itself. Okay, and then I am returning it over here. Let me just complete the program so I can explain it to you what I am doing over here. And int star marks equal to square. Right, compile the program and check. Warning, function returns address of local variable. Okay, you have to make it static. because I've commented it out. Great. Right. So let me explain what I just did right now. This is a function which returns an array. Okay, I removed the thing over here so that the program doesn't become unnecessarily complicated. Okay, it will be meaningless to pass an array then make the function pass the array back. Okay, you either pass the array to the function and don't make the function return the array, or you don't pass an array to the function and make the function return the array. You do either of them. You don't do both. Doing both will be meaningless, although it will work, but anyway. So what I did here is that I put the return type of the function as int star, then the name of the function, then an empty set of parameters, starting scope, integer I, then I declared an array static int marks 10. So as you can see over here, this part is familiar to you, since I've already told you that this is the data type for the array and this is the name of the array followed by the size of the array. But what is this static over here? Turns out in C, if you are trying to return an array from inside a function, right? So I declared this function, I declared this array inside the function, right? So what will happen is that the visibility or availability of this array will be only inside this function. Now if I want to return it and try to use the array somewhere else, I will have to declare it static. Now what static does is that it simply expands the visibility of this array beyond this function. Okay, so what I'm telling is that even though this array is declared inside this function, I cannot access this I over here in main. This I is only available inside the function square. I'm using a separate I over here, that's why there is no conflict. Okay, but if I want to return this function over here, return this array over here, I have to declare it static. Okay, so that its visibility increases and I can use it in my main function. Okay, this int star over here, it is actually denoting that I'm returning a pointer of data type integer. Okay, for now let it be sufficient to know that pointer is basically pointing to the memory location, right? Just like the variable marks is pointing to the first memory location, it's basically a pointer. Okay, and since I'm declaring it as int, this is an integer pointer, and that's what it's returning. Okay, we'll be covering more of pointers later, and then I am assigning it a value to each of the memory locations, normal, just like we did, and then I'm returning the pointer to the first location. Okay, and then inside main what I'm doing is that I'm calling this function, but this looks a bit odd, right? Int star marks equal to square. I believe we have covered this part before, except this data type was different. If an integer was returning if a function like this square over here was returning an integer, this would have been an integer variable. But since this function returns an int star, an integer pointer, we are going to make this an integer pointer as well. Okay, so the pointer that's returned from here gets stored in this variable, and then we can operate with it just like a normal array, right? So this is how we can easily pass an array from a function to another function, right? So I hope this was clear, how to create an array, how to initialize it, how to pass an array to a function, how to return an array from a function, and what an array basically is. In the next episode, I'll try to start multi-dimensional arrays. That will take a long time to understand, but before I start multi-dimensional arrays, I think it will be better if I cover pointers. Okay, I'll think about it. Or if you feel like, you can leave your feedback in the comments about what you think. Leave a like if you have understood, leave a comment if you have any doubts, and I'll see you in the next episode.